Simplified Physics. Welcome to Simplified Physics. In this lecture, we will discuss on relative velocity. This is the third lecture on kinematics. In the previous lecture, we have discussed basics on kinematics. And don't forget to subscribe and share the Simplified Physics. Let's begin today's lecture. Before beginning the lecture, you may have idea about the addition and subtraction of the vector. So before starting the relative velocity, you may get the ideas about the addition and subtraction of the vectors. And for this, I suggest to see the lectures on the vectors, and for the lectures on the vector, you may quick search vectors has one simplified physics or vectors has two simplified physics for addition and subtraction of vector. Now, what is relative velocity? In fact, relative velocity is the time rate of change of position of an object with respect to another object. That is velocity of a body with respect to the second body or observer is simply relative velocity. And alternatively, we can define the velocity seen by a particular observer or a frame of reference is simply the velocity relative to the observer or relative velocity, and frame of reference is simply the coordinate system with a time scale on which an observer will be there. That is the frame of reference. How can we find relative velocity? Simply suppose two bodies A and B are moving, making an angle theta with the velocities BA vector and BB vector. Velocities BA and BB. Body A is moving in this direction, and we have an observer B is moving with the velocity BB with an angle theta. Then to find the relative velocity of A with respect to observer B, we reverse the velocity of a second direction of a second vector BB, and that is negative BB in this just opposite direction of the direction of the BB. And the resultant obtained by using the parallelogram of addition of vector gives the relative velocity of A with respect to B. That means R equals to simply BA minus BB. Once again, to find the relative velocity of A with respect to B, we just reverse the second vector. That means the second velocity, that is the velocity of the observer, is reversed, and using the triangle law or parallelogram law of addition of vector, we can simply find the relative velocity, that is the resultant of the addition of these two vectors. In fact, VA and B minus BB gives the relative velocity of A with respect to B, and the relative velocity of A with respect to B is BAB equals to BA vector minus B vector. Or you can just simply using the triangle law R vector, just shift the vector A in this side and negative of the vector B is here. So simply R vector using the triangle law minus BB plus BA, that is simply BA vector minus BB vector. Similarly, the relative velocity of the B with respect to A will be BB vector minus BA vector, that is BBA, relative velocity of B with respect to A if A is an observer, so BA vector minus BA vector. And how can we find magnitude of the and direction of the relative velocity BAB vector? And simply using the triangle law or parallelogram law, we can find BAB will be square root of BA square plus BB square plus 2BA BB cos an angle between BA vector and BA minus BB vector is 180 minus theta. That is simply BA square plus BB square minus 2BA BB cos theta. That is the relative velocity, magnitude of relative velocity of A with respect to B. Similarly, direction can be found by using the relation tan alpha equals to BA vector relative velocity. Alpha is the angle between relative velocity with the negative vector, that is BA sin 180 minus theta, BB plus BA cos 180 minus theta simply gives the BA sin theta by BB minus BA cos theta, and alpha equals to simply tan inverse BA sin theta by BB minus BA cos theta. In this way we can find the magnitude and direction of the relative velocity BAB, and for this relation I suggest to see the previous lecture on vectors. And similarly, magnitude and direction of the relative velocity BBA can be found as BB equals to BA square BB square minus 2BA BB cos theta, and the angle made by the relative velocity with the negative of the B vector, that is tan inverse BB sin theta BB minus BA cos theta. In this way we can find magnitude and direction of the relative velocity as well. Let's see some special cases, and for the special cases just remember the specific relations for the magnitude and direction. Very first case, when an object A is traveling with the velocity BA and an observer B is at the rest, in such condition BB vector equals to 0. The relative velocity of the A with respect to B is BB equals to 0 is simply BA itself if observer is at rest. When an object A and observer B are traveling in opposite direction with the velocities BA and BB, in such condition, and the magnitude is simply given by BAB equals to BA minus BB. Simply apply in this case theta equals to 0. If they are traveling in same direction, both observer B and object A are traveling in the same direction, angle between them is 0. In such condition, the magnitude BAB equals to BA minus BB, and direction will be 0. Just apply this relation, find the direction, that will be 0. Second case, if they are traveling, third case, if they are traveling, some mistake here, when an object A and observer B are traveling in opposite direction with the velocities BA, an object is traveling, and BB is traveling in opposite direction with the velocity BB, in such condition magnitude is BAB equals to BA plus BB. Just apply this relation, or simply we can say BA plus BB, and direction will be 0. Let's see some applications of relative velocity. The very first application, river boat problem. Boat to cross the river along the shortest path. First sub case within the river boat problem. Boat to cross the river along the shortest path. Let us suppose the river is flowing from left to right side, and boat to cross at the shortest path. That's the condition. Let A be the point at which boat is at initial point or starting point, and B is directly exactly opposite to the point A in the shore of the river, on the shore of the river, and the condition is boat should follow the shortest path AB, that is the AB, and the river flow will carry the boat downstream as the boat crosses the river. If boat crosses the river, because of the flow of the river, it will pushes the downstream. So in such condition, for the shortest path, the boat should be rowed upstream, making an angle theta with the AB. So in such condition, the relative velocity will be B equals to P1 vector minus P2 vector, and magnitude and direction. The magnitude of the B is simply use the Pythagoras theorem. B magnitude, the resultant velocity B equals to square root of P1 square plus P2 square. That means the boat moves across the path AB with the velocity B if the boat is rowed upstream, making an angle theta with with the with AB. In such condition, boat will cross across the AB, that is the shortest possible path. And note on the time of the crossing of the boat T will be AB by the velocity, magnitude of the velocity, relative velocity B, AB by B. And angle with which the boat should be rowed is simply use the trigonometry function sine theta equals to V2 by V1, that is perpendicular by hypotenuse. In this way we can find direction with which the boat should be rowed and also time for the crossing, knowing the shortest path to cross the river AB. Let's see an example. A river is flowing from west to east at a speed of 5 meter per minute. In what direction should a man on the south bank of the river capable of swimming at 10 meter per minute in a still water should swim to cross the river along the shortest possible path? Okay, let's see the diagram. A river is flowing from west to east according to the question. For the shortest path, the resultant should be AV. Resultant velocity or relative velocity will be AV, and boat should be rowed making an angle theta upstream, so that the boats should cross the shortest path AV because of the flow of the river. And with reference to figure, we can use the sine theta equals to B2 by B1, that is 5 by 10. B2 equals to 5 meter per minute, because river is flowing, V2 river is flowing 5 meter per minute, and V1 velocity of the swimmer is 10 meter per minute, that is simply divide 1 by 2, and sine 30 degree equals to simply 1 by 2. So we can say theta equals to 30 degree, and the swimmer should swim at 30 degree west of the north upstream, 30 degree west of the north, so that the swimmer can cross the path, to cross the river along the shortest path. And this is the end of the lecture. Thanks for watching. Don't forget to subscribe, share, like and comment. And for the further lectures, you may search using the specific phrase. This for the vectors, vector S1 simplified physics or vector S2 simplified physics, similarly dimensional analysis, S1 simplified physics, S2 simplified physics, and so on. 6 different lecture on the dimensional analysis. At the end of the topic, thanks for watching, and the very next lecture will be the 4th lecture of the kinematics or relative velocity, second lecture on the relative velocity. Thanks for watching.